All right, folks, got a little video here for you. Mr. T's gone at tennis, and I got little circles for you. Okay, a lot of this should be review stuff that you have seen in middle school, maybe even like fourth or fifth grade stuff. We're gonna jump into it. We're on our new and our last chapter. This is the last chapter that we are gonna do together. Congrats, we're almost there. Probably got like 5, 6, 7 lessons of new stuff. Then we're just gonna study for, or fine, we'll have a quiz in there somewhere. But 10.1 is circles and circumference. Okay. And 10.1. So you know how these chapters always start very heavy on the definitions and that. So again, if I'm going too fast, pause, take nice notes, make it look good. It'll help it get in your brain. Let's jump into it. Circles and circumference today, 10.1. Here's the definition of a circle. Okay, it is the set of all points in a plane equal distant. They spell it like this. Equal distant is also like equal distant from a given point, the center. So we got C is the center point. All the points are the same distance away, and that makes a circle. Isn't that cool? So you might see circle as in like circle C, or this got this little circle with a dot and C. Those might be some ways that you might see circle out there. So keep an eye out for that. Again, you need to write that down, pause it, do it. We also have a radius, okay? Or if we're talking about multiple, we would say radii. It's a segment with endpoints at the center and on the circle, okay? So if we drew one on our circle picture on the top, right? If we had something like this, where it goes from the center, that was a really nice straight line. That was impressive. We go from C to, I don't know, we call this X. Okay, CX would be a radius. Okay, we could draw another radius. Okay, all this Y, CY would be a radius. All right, you guys know that one. That's a classic. It's a classic. Probably learned that in 5th grade. Ooh, a chord is next. Okay, this one maybe is a little less known. A chord is a segment with endpoints on the circle. So we could have something like this. Okay, and maybe we'll call this WZ. If I can make a Z, geez Louise. Okay, so WZ would be a chord, but there's also a more famous chord. Anybody know what it is? Anybody know? Yeah, Claudia, go. A diameter? Yeah, you got it. You got it. So there's a very famous type of chord. It's an example of a chord called a diameter. Okay, a diameter is a chord that passes through the center. Okay, so it's a chord that passes through the center. Like if we did this, tailed off a bit there. You get it. If it's straight, that wasn't straight. You guys can draw it better than me. So AB would be a diameter, or there's a better one on this picture down here. DE is a diameter. It's a chord, but it goes through the center. And then look at this little bit, made up of collinear radii. So it's basically like two radiuses put together, okay? So CE, if we look at this picture down here, CE is a radius, and so is CD. And those two together, because they're collinear, they're on the same line, they make the diameter DE, okay? Really kind of good, fun stuff. Circles are cool. There's a lot to them, and they're really cool. All right, again, if you're still writing, pause, write, pause, write. Let's see what else we got. All right, so we can go through and we can name some stuff. Okay. What do we got? Jewel, what do you got first? Name the circle. You said circle C. Yeah. So we want to name the circle. You can go circle. We could call it circle C. You could do this little dealio. Wow, that looked terrible. That looks so bad. Oh my God. Doop, doop. So we could go circle C like that. Liam, what do you got? Liam says, sorry, we're now on a radius. Liam, what do you got? XT. XT is a radius. What's that, Albie? XV? Yeah, XV is a radius. XU is a radius. And ZX. So we got 4 radii there. Chords, there's 2. There's RS. Can anyone get the other one? Janie, what do you got? ZT. Yeah, ZT is a diameter and a chord. Okay. So ZT is a diameter and a chord. I'm not going to write these all out because I got them right here. Plan ahead. Okay. So we got circle X, and here's our 4 radii. We got chords RS and ZT, but ZT is also a diameter. Special. It's special. All right. Again, need a little time to write that down. Pause it. Check it out. Okay, so now we're going to do a couple circle pairs, talk about these. Got a couple things here, a couple of pieces of information. Yeah, these are just interesting little pieces of information. So 2 circles are congruent if and only if they have congruent radii. Okay, remember, if and only if goes 2 ways. Okay, the first way is if you know 2 circles are congruent, you know they have the same radius. The other way is if you know 2 circles have the same radius, then you know they're congruent. So as long as you know, like if we know JK is 5 and GH is 5, we know that both of those circles are congruent. So it's pretty easy to show circles are congruent. They just need the same radii. It's not like triangles where we have all these rules and shortcuts. Really simple. Okay. The second one is also really nice. All circles are similar. Every single circle is similar, right? What does similar mean again? Yeah, that's right. It means that it's the same shape, different size. Okay. Circles have to be the same shape. A circle is a circle, is a circle, is a circle. Okay. So they got to be the same, but they could be different sizes, smaller, bigger. Remember, blow them up, shrink them down, but all circles are similar. Okay. And then we got this other cool one. Sorry, I can't even talk. Concentric circles. Concentric circles are coplanar circles that have the same center. Okay. So there's circles that are in the same plane that have the same center, but they might be different sizes. And those are concentric. They're like within each other. Russian nesting doll. You know what I'm talking about? Nice. Okay. What do we got down here? All right. And then here's a little graphic for intersection points. So we could have like a Venn diagram situation here. The story I told 3rd period was, you guys remember you're like in kindergarten? And like, this is the one I remember. It's like every kid got a green and a black olive, and you ate them, and then you said, do you like green, do you like black, or do you like both for olives? And then I was the weird kid that didn't like either. So I was this kid. I was like down here. I hate both. Now I like olives, but anyways, so you could do Venn diagram situation, 2 points of intersection, give you that middle part. But these circles are congruent, right, in a Venn diagram. You could also have something like this where they're different sizes and they still intersect. And then we got 1 point of intersection. So you got this where it's kind of going through the middle here. Wow, cannot draw a straight line. Going through the middle here. That would be 1. Or you have a concentric circle. Well, these aren't concentric because they don't have the same center. You have a circle within a circle and they're touching. Okay, we're going to see this come back up a lot, and you'll see it a lot more in math later. These are going to be called what lines? Tangent lines. Nicely done. Why can I not draw, dude? I am so sorry. Yeah, that's better. It's a tangent line there. So we'll see that come up. Super important in math. Tangent lines are like the bread and butter of calculus. So, and then we got no points of intersection. Here's our concentric circle over here, one within the other. And then you just got two circles that have nothing to do with each other. See ya, buddy. Okay, so we got that. Cool. Let's do a problem now. Let's do a problem again. Ooh, that just gave everything away. Don't look. Why would I do that? Okay. Hopefully you didn't see that, but let's do a problem. So we know the diameter of S, okay, that's this big circle, is 30 units. The diameter of R is 20 units. DS, this distance here, let's draw that in, is 9 units. Okay. Now, if our diameter is 30 units, what is our radius? It's half, right? So radius is half of the diameter. So CS is our radius for the big circle. So that's 15. And then we know the radius of the smaller circle, which is R to D, is 10. Okay. Now, sometimes this can look a little confusing. You have a problem like this on your homework. But if we drew this out down here, if we like separated that, that's a straight line. Let's go. This is RS. Okay, and then within that, we have DS, which we know is 9. Sorry, D here. DS is 9. And then RC is what we're trying to find? No. CD is what we know. But we know RD, there's C, is 10. Okay, and then geez, we got so many things here. CS is 15. So there's a lot of data here. We kind of got to wade through it and see what we want. But you can see here that if CS is 15 and DS is 9, then CD has to be 6. So that's new information. I'm going to put it in green. Okay, so CD is 6, so we wanted to find that. So let's put that as 6. And then what if we wanted to know RC? Well, we know RD is 10, so RC's got to be 4. Okay, so you can find all these little missing stuff and put that in. So you got a couple of problems like that. Okay, let's see if we got it right. Yeah, we got it. Brilliant, brilliant. Okay, so here's another one kind of like that. I think we get the gist. You with me? All right, here we go. New topic. Make sure you have this. You probably already know this, but it's a good reminder. Circumference. There's 2 ways you can do the circumference. It's either pi times the diameter, or it's 2 pi times the radius. So if you have the diameter or the radius, you can easily find circumference. Okay, it does not work the same for area. So let's keep that in mind. But for circumference, we got pi times diameter or 2 pi r. Okay, and remember pi is just a number. It's 3.14 or something. Okay, it's just a number. This is annoying. Let's just find, if you need to write that down, pause, write that down, really important. Let's find a problem. It's not what we want either. All right, let's just make a problem up. Okay, we got a circle. Terribly drawn. The radius is 10. Let's find the circumference. Okay, circumference is 2 times pi times r. Okay, r is 10, so we're going to do 2 times 10 times pi. So that's 20 pi. Now, sometimes we might want to leave our answers as exact values. Okay, so we could leave the answer as 20 pi if we want it inexact. But if we want to approximate or find a value, see if it makes sense in our mind or something, you can plug it in your calculator and just do, you make sure you multiply times pi and not just 3.14. We want all the decimals there. So this comes out to 62.83. units, whatever unit we're in. Very simple. You've been doing that since you were like 12, right? 11. You've been doing circumference for a while. Nothing crazy there. Now, there are some where we're going to want to work backwards, okay? So here is the circumference. We want to find the diameter and the radius, okay? We want to find both. So if we want diameter, it's a really easy equation. Circumference is just pi times the diameter, okay? So to find circumference, or I'm sorry, to find diameter, we have the circumference, we can just divide by pi. Divide by pi, and we get diameter is equal to circumference divided by pi. Okay, and we just do that. Okay, so circumference was 21.2, so we're going to do 21.2 divided by pi. Again, use the pi on your calculator, not just 3.14. Let's try to be accurate, kiddos. And we get diameter is 6.75. Okay, and then if we want the radius, what do we do? Stella, go ahead. Divide by 2. Yeah, just divide it in half. So we just do that divided by 2 gives me the radius, which is 3.37. Okay. Nothing super crazy there. Let's see. This problem's not that bad. Okay, last problem, then we'll stop this. There might be some where you got to use a little Pythagorean theorem from last chapter. Okay, you just took a test on this, you feel good about this. But here they want us to find the circumference, but we're going to need to find the diameter, right? So for like number 7, we need to know the diameter here. These chords don't help us in any way. So we'd have to do 6 squared plus 8 squared equals, we can call it c squared if you want, or it's the diameter, so you could say d squared if you want. And then let's see what this is. So that's 36 plus 64. Well, it comes out to 100. Isn't that nice? So diameter squared is equal to 100. So the diameter is equal to 10. Okay, now you can find the circumference. Now we got our diameter. We're going to do circumference is equal to 10 times pi, which is 31 something. 31.42. And we are in centimeters. Okay, so you got a couple of those on your homework. You might need to use a little Pythagorean theorem to find a missing side, but it shouldn't be too bad. Okay? There, we got it. We got it right. Got a little homework. If any of this is confusing, go back, check the video, double check yourself, and hope you have a great day. Sorry I wasn't able to be here, and good luck.